Okay, I have one question, but hopefully people have other questions. All right, let's do this one first. So, the question is, why is this 2-cyclobutyl 3-methylpentane? Oh, here you can grab. That's fine. So why is this cyclobutyl? The question, the way we determine what is the parent chain for cycloalkanes is the substituent, does the substituent have more carbons than the ring? Or does the ring have more carbons than the substituent does? And so in this case, there's a 4-carbon ring and a more than 4-carbon substituent. So the way that we name this is to say, okay, there you go, is to say, okay, since I've got a bigger chain, I'm going to use the just normal alkane rules, and I'm going to call the cyclobutane ring an alkyl group. So I would look for the longest continuous carbon chain, and I'm just going to treat this as if it was like a methyl or an ethyl or isopropyl or something. So in this case, I've got, I think this is the longest chain, and I cannot involve anything from the ring. So then in terms of substituents, this is a cyclobutane. When it becomes an alkyl group, it becomes a cyclobutyl group. And then of course here I have my CH3 group, which is my methyl group.
Can you not involve the one coming off of the cyclobutane?
No, you never do that. Yeah, never. It's got to be a longest continuous carbon chain, and the ring cannot be part of that. Because, yeah, the ring can't be part of it because otherwise it's not continuous anymore. So the whole ring is a substituent. So now we just use alkane rules. Number from the end closest to the first substituent. Over here it'd be 1, 2, 3 to get to the methyl group. Here it's 1, 2 to get to the cyclobutyl. So it's a 1, 2, 3, 4, and 5. So it's pentane. And that's basically it. For cyclobutyl, since it's all one word, it's alphabetized on C. Okay, only when there's hyphenation do you discount the first part. And then, of course, the di and the tris that are outside of parentheses. So cyclobutyl is alphabetized on C. So this would then be 2 cyclobutyl and 3 methyl. And then finally the parent name, which in this case is just a pentane.
In this case, you number it from the top, so from left to right. Was that because when you add them together, you get 4?
No, that's only for cycloalkanes. That's only if I'm numbering cycloalkanes. In this case,
This
has the cycloalkane as a substituent.
Oh, okay.
So the fact that it's a cyclobutyl group is no different than if it was isopropyl, tertibutyl. It's just a substituent. So I numbered at the top because I wanted to number from the end closest to the first substituent. And the first substituent is the cyclobutyl group.
Okay. Thank you.
So that's the 2. So that's why it's 2-cyclobutyl.
So when it comes to the test, are you going to have us write out the names? Because so far we've always had multiple choice to figure it out.
I know, that's a disadvantage, isn't it? So it means I need to write some naming problems for you to name.
Yeah. Is there a way to also like last night or like this homework for due today? There was like a lot of different
I know.
timings. Like, is there a way to remember it without confusing it all in your head?
Probably.
So how do you? I don't know.
So how do you do that? Well, each person has to come up with a system to do that. No. What I'll try and do because we're ending this on Wednesday, is maybe go through and just put the rules together. What I've done in the reading is I've highlighted the important steps in the rules. But there are some overall rules, and then every molecule may have a unique thing, including this chart, which we can talk about. So yes, you will have to, unless I decide to make it multiple choice, you will have to write out the name. But aren't you kind of writing the names out anyway when you're, oh, that's not good. Maybe we'll have to do one of those problems. Bobby?
We have to draw them on the exam too, because we haven't had any problems like that, so I don't think it would be reversed.
It could be, but I'll put together sort of a big homework problem set where you can get practice doing that. Okay, so is that okay with this problem? All right, what other questions do you have?
I didn't get number 49. How to figure it out?
I didn't get 49. What is 49? Okay, number 49. So you're not writing the names? You're not writing the names and then seeing if it's there? Oh, there's a new way of taking multiple choice tests that I don't know about? Other than finding the answer and then finding what letter that answer is?
See what's wrong with all the other ones. Yeah. If you choose the one that looks the least wrong.
Now, you could actually, if you've tried to draw the structures from the names, usually people get that 100% of the time. Drawing the structure from the name. But drawing the name from the structure is a whole other story. So what I usually suggest is people are writing names out. When you're done, cover up the structure and see if you write the same structure from that name that you just drew. Because if you do, then you're fine. If you don't, then there's something wrong with your name. Okay, so this one is that. So there's an isopropyl group with the oxygen. Okay, so when we see the molecules with multiple functional groups, we need to go to this chart. Right? And the usefulness of this chart is that it gives me the priorities in the functional groups, which, as I think we found out on Friday, it does not obey the Con-Ingle prelog sequence rules. So you will get this chart to use in naming. But if I'm looking at the different functional groups that are present in this molecule, what do I have? What functional groups are present in that molecule? And here's the thing, you need to know the functional groups before you can use this chart, because if you don't know what the functional groups are, you can't look them up on the chart. So we'll come back to that. But what functional groups are in this molecule? No. That's a BR. So there's a halogen, but it's not really a functional group. What else do we have? Okay, so we got an alkyl halide. What else? We got an ether, which is an oxygen with 2 carbons on either side. And what's the last thing that we have? What?
A butene?
How about an
Or
alkene?
aldehyde?
An alkene. So we've got an alkene. We've got an alkyl halide with the bromine. And then we have an ether. So of those then, which one's the highest priority on this table? Well, what I see is I see an alkene, and then I see alkyne, and then I see halogen, alkyl group, and alkoxy group. So an alkoxy group is an alcohol that's basically a substituent. And those are second to last in terms of priorities. So the double bond is the highest priority in this molecule. So this is going to be named an ene. Something ene. So that's why we need to know our functional groups, and we need to know this chart.
Wait, I'm sorry. Could you go back? So the alkene I see. Where do you see the alkyl halide?
So this is an alkene.
Yeah.
This is the alkyl halide. And on that chart, it's abbreviated as X. X is a halogen atom. And then this is the OR group.
Okay.
So the critical part of this is alkyl halides and the alkoxide groups are treated again just as if they were methyl, ethyl, propyl. There's nothing special about them. If they're at the bottom of the list, they're just substituents. So I now have to find the longest continuous carbon chain that has the alkene in it. And so it's going to be that one. You could say, why didn't you go through the O? Because the O is not a continuous carbon chain. So I can only have the carbon chain, and then that leaves my substituents. Bromine is called bromo, chloro, iodo, fluoro. And then this group right here, the alkoxy group, you name that by naming the common name of the alkyl group that's attached to the oxygen. So when I look at this, I got a CH with a CH3 with another CH3. So what kind of alkoxy group is that? Isopropoxy. But isopropyl is the alkyl group, so this is an isopropoxy group.
An alkyl halide is an X attached to another carbon atom, or organic, because that's Earth. So Br, is that it's attached to an alkene group? Does that alkene group count as that? Is that R?
Yeah, it still counts as that R.
Okay.
R is any carbon group. It can have a double bond or a triple bond in it. So it's really just a generic carbon-based group.
Okay, so you're trying to be able to find a functional group in every single compound, every single product you want.
If not, it's just an alkane with nothing but substituents.
Okay.
So in this case, it's an alkene with 2 substituents. Okay. So then I put the name together. Well, how many carbons do I have? 5. Numbering from right to left, left to right. Right to left because I've got a number closest to the double bond. So there are my 5 carbons. So this is a pent 1-ene. You're right that it's a pentene, but I need to tell you where does the double bond go. The double bond goes on carbon 1, between 1 and 2. So this is a pent 1-ene. Then I alphabetize the remaining substituents. So this is going to be a what? It's going to be a 2-bromo. Four isopropoxy pent 1-ene.
So you never found the bond between the parent chain and the oxygen?
Right.
Okay.
Because oxygen's not a continuous carbon atom. So we leave it as its own substituent.
Can you put dashes in between everything?
Probably for the isopropoxy, there shouldn't be a dash. It just should go right into pent.
Okay, how?
The dashes go between numbers and letters. Commas go between the numbers. And then for the last one, it's usually just all one word. So it's normally like 4-isopropoxy pent, all one word.
So if there's not a number in between the 2 words, you don't
Then
have
you don't
dashes.
have dashes and you don't have commas. Right, so that would be the name of this. That would be the name of this molecule. So again, what I need is, I need to know what the highest priority group is, because that highest priority group has to be part of the longest chain. And it's going to give me the name.
What if the highest priority isn't part of the double chain? Like if there's a double bond, then that's part of the substituent. Because don't you always have to have the double bond within the parent chain?
Yeah, and so there's some groups that can be part of the longest chain, and we should make them part of the longest chain if possible. So things like the double bond can be part of the longest chain. The triple bond can be part of the longest chain. A carbonyl of a ketone group can be part of the longest chain. So where these functional groups are present and they're not the highest priority, they will be part of the longest chain, if at all possible. And if you look at the rest of the functional groups, they're kind of hanging off the side. They're kind of hanging off the longest chain. They would be making a beginning of a chain. What else?
I'm excited to use this to tell which functional group matches on this chart.
Okay. For instance,
like, I don't really understand the brackets around, like on the fourth one, the oxygen.
okay, a bracket on the oxygen means that it's a C double bond O. So this structure is C double bond O attached to an O attached to a C with another double bond O. So the structure on the right is the structure on the left. And at the top, the brackets C OOH is a C is a COOH. So it's carboxylic acid. I don't know why there's brackets on like the C triple bond end. And then right underneath it there's a C triple bond end. Oh, I do. Yes, I do. Never mind. So the difference between those two is whether the C triple bond N is part of the longest ring or whether it's a substituent. The better example is this bracket CHO is an aldehyde. A CHO group is a C. When you see CHO, it means C double bond OH. It means aldehyde. But the bracket CHO is when it's part of an alkane longest chain. And the CHO that says carbaldehyde is actually when the CHO is attached to a ring. Is attached to a ring. So there are a couple of those exceptions. But I don't think we'll necessarily go that deep. Although the book may go that deep. But that's what that means.
Did you say it means it's attached to a ring?
I think the ones without the brackets. If there's two of them and one with brackets and one without, the one with brackets means it's attached to a non-ring, and the one without the brackets means it's attached to a ring.
What is like the lesser greater sign mean? Less than sign that's down with the E and A.
Yeah. So with like this.
Yeah.
Means that. So what they're trying to do is they're trying to draw a structure on a typewriter without drawing a structure. So that greater than symbol is trying to show you that that carbon is attached to two other things. And it used to be in the old days, apparently the old days have passed, that for instance for the first one, I would write a C, then in brackets a double bond O, then an O, then a C, then in brackets a double bond O, like that. Which I can do with a typewriter. Right. So that you'll also see. Because again, it's just the idea that I'm trying to do as much as I can with a keyboard as opposed to drawing. But then this is that. Which I think next time you'll find is what's called an anhydride. Carboxylic acid anhydride. So you might have to go through with this chart, and you might have to, or I might have to, expand all of those structures. Maybe I'll do that for Wednesday, and maybe I'll bring in another more fully written out chart. And there's some names on here that I've never seen, like AZAME, never seen it. Azanal, never seen it. Azanaladine, never seen that. So we usually use amine, imine, amino, or imino. So I should probably have whited those out, but I can't white them out in the book. But that's how we use the chart. The chart's going to tell us what the priorities are. What other questions?
What is your aldehydes and ketones?
Aldehydes and ketones, naming them? Okay. So aldehydes and ketones, aldehydes, since they're at the end of the chain, will always dictate the beginning of the chain. And what do I mean by that? Well, let's say I've got an aldehyde here. Oh, we'll just make this as complicated as I can make it. Here, I'll give you a real one. I put something similar to this in the super freezer because I just ordered it for research. So here's this aldehyde. Now, it's got a ketone functional group, it's got an alkene functional group, and it's got an aldehyde. So again, first thing I got to do is identify those three things. So I'd say, okay, yes, here's my ketone, here's my alkene, and here is my aldehyde. And so now I have to look at my chart and I have to see which one of these is the highest on the chart. And it is aldehyde. So it is. The aldehyde is the number one group on this chart. This chart, the way they did it was anything that occurs at the end of the chain is automatically going to get the number one position. But then they went through and delineated that. So when I look on here, I see, yes, an aldehyde is the main group. And so in the middle column, it says that if an aldehyde, and I'm using the aldehyde with the bracket, CH, because it's attached to an alkyl group, or a non-ring, then that means that this gets a suffix of al, and it is the last name in the molecule. So the number one group always contributes to the last name of the molecule. And what do I mean by that? What I mean by that is, here's my longest chain. Now I've got to number it closest to the number one priority group. So when the number one priority group isn't the end, this is automatically 1, 2, 3, 4, 5, 6. Whoop. I just wanted 9 carbons. I didn't want 10. Okay, so I've got 9 carbons there because I just erased the last one. That's going to make this a non-al, except, well, we'll just leave it at that for the moment. So that's where the AL goes. The AL goes after the total number of carbons in the longest chain. So then I look at my other two functional groups and I determine, well, can they be part of the longest chain? And the answer is double bond, yes. Ketone group, yes. So I mean, the longest chain includes those two functional groups, but they are not the number one priority. So if I want to know what to call the alkene, I go to the chart and it says ENE. So we've done that before, right? So this is going to be an ENE, but we haven't done ketone before. So the ketone is this one. That's the ketone. So the ketone says that it should be ONE when it has the priority, and when it doesn't, it becomes an oxo group as a substituent. Sure, they're yours. And I'm going to write all over it and bring you a new one on Wednesday. So, but for the ketone, since it's not the highest priority, this is going to be called an oxo group. That's how we read the chart. So if any group is not the highest priority, then we use the middle row to determine, well, what is it then as a substituent?
Is it a prefix though? Because,
Oxo?
yeah.
Well, prefix if lower precedent. I'll show you what I mean by that. It's not actually, it's a prefix if it was like the only other thing that was there. But it's, what it really should say is it's the substituent. It's the substituent name. All right, so now my non-anal is no longer a non-anal, is it? Because it has a double bond in it. So when you have a double or a triple bond, that gets incorporated between the number of carbons and the final suffix. So instead of this being a non-anal, it's going to be a non-enal. And so what I need to do is I need to tell you where the position of the double bond is. Now, aldehyde is automatically assumed to be number 1, so there doesn't need to be a number 1 in front of the al. So in this case, what's the first carbon in the double bond? Carbon 3. So this is a non-3-ene al. Okay? So then I look at my substituents, and basically what's left is the ketone, which is called an oxo group. And it's not really a substituent in terms of it hanging off the longest chain, but it is part of the longest chain. And so what I would do is treat it as a substituent and say this is 5-oxo non-3-enal.
Do you need a dash between the oxo and non if there's not a number there?
No, but I think they put a dash there.
Okay.
When I grade, it's not a big deal, but I do think there's a dash there
Okay.
because it's a there. I know there's a dash there. Although, yeah, you could get away with it either way. There's one part I'm missing of the name. Whenever you have a double bond, you need to go back and make sure it's cis-trans or EZ.
What about the two double bonded O's that are substituents from the other?
So this whole group right here is what we're calling the oxo group. So when I say 5-oxo, I mean C double bond O.
So when you use substituents, that's a regular alkane.
Yeah, well, yeah. This oxo group is weird because it's named as a substituent, but it's part of the longest chain. It's the only one that's like that. Right, so what's the double bond? Trans. So again, we look at the double bond. There's a hydrogen here and a hydrogen there. When I have an alkyl group and a hydrogen on both carbons, I can use cis or trans. In this case, both hydrogens are opposite, and so therefore the correct name for this would be trans 5-oxo non-3 phenol. So cis or trans can be used whenever there are basically two hydrogens attached, one hydrogen each, to the two carbons in the double bond.
You use the all the time? Or-
Yes. You could use E and Z all the time, so you could call this trans, or you could also call this E. So yes, you could use E or Z. You have to use E or Z when there's 3 non-hydrogen groups attached to a double bond. So once there's 3 non-hydrogen groups, it's got to be E or Z. So this would be so that's, you have to put cis or trans in front or E or Z in front.
So then right here there's H on top and H on the bottom, but wouldn't you be measuring, wouldn't, like if you put in the carbons, wouldn't those be the, I mean it would still be trans, but wouldn't those be the highest priority then?
Well, see, that's the thing with cis or trans. It doesn't matter what I look at. If I look at the higher priority carbons or I look at the lower priority hydrogens, I can get cis or trans. I'll get the same answer. So I just use the hydrogens because
Oh, okay.
it's a little bit easier to see. But if there's only one hydrogen there, I'd have to use the E or Z terminology. I don't have a choice. If it's just a ketone, like let's say something straightforward like that, if the ketone is the highest priority, then I just would go through and find the longest continuous carbon chain that contains the ketone carbon, number from the end closest to the ketone, number and alphabetize my substituents, and then put the name together saying that this would be a 5-chloro 2-hexanol. Hexanol. It's ketone. And again, looking back at the name, we've got a 6-carbon chain. It's a ketone with a ketone with C double bond O at carbon 2 and a chloro group at 5. Yeah, so it could be this too. Chlorohexane 2-one. I think it's the correct one. The problem is there's an old system and a new system. The old system always put the number in front of the pent or hex or whatever. And then they came up with this new system, probably because you couldn't put more than one number in front of the pent. So if you had two different functional groups, like we had our enes and ynes, then we probably shouldn't put two numbers in front of it. We probably should put the number in front of the ene, then a number in front of the yne. So this is actually the correct system. I may slip back into the old system from time to time. What else? $54. Okay, what's the name of that molecule? So what's the name of this? Well, tell me what functional groups I have. Got an aldehyde, organic, an alkyl halide, alcohol, and alkene. So of those, which is the highest priority? Which one's the highest priority? Aldehyde. Because it's the end of the chain. So that means now I need to find the longest continuous carbon chain that contains the aldehyde. And since I have an alkene, I need to have the longest continuous carbon chain include the alkene as well. So there's my longest continuous carbon chain. Now let's go ahead and number it from what? From the aldehyde, because it's number 1 automatically. So I've got an oct. So that's an oct. What oct is it? Do we agree? So the aldehyde's on carbon 1 by automatically. There's a double bond in the longest chain that starts at 3 and goes from 3 to 4. And it's an 8 carbon longest carbon chain. Correct? Well, let's go through and look at we'll look at the substituents here in a moment.
What is the suffix
Aldehyde. Right. So now let's look at our substituents. We've got a bromine at what? We've got a 2-bromo. What else do we have? Let's take 6. 6 what? 6 methyl. All right, what do we do with the OH group? Again, we consult our chart. And our chart says that an OH group is called a hydroxyl group if it has lower precedence. So if it has lower precedence, it's called a hydroxyl group. So what kind of hydroxyl group do I have? I got a 5. So now we just go ahead and alphabetize the substituents. So we've got a 2-bromo, 5-hydroxyl, 6-methyl, octene 3, oct 3-ene al. Oh no, it's part of the longest chain. Yeah, that's why we want to circle that longest chain. So when we look at it, we might start to see substituents, but they have to be real. And so it's not because it's part of the chain.
And you use the AL because it is part of the chain, right?
Well, I use the AL because it's an aldehyde and it's the number 1 priority group. So it comes at the end.
But instead of using the carbaldehyde.
So the carbaldehyde, yeah, I'm going to specify that. Carbaldehyde, I'll show you. That is cyclohexane carbaldehyde because it's got a ring.
Okay.
So the ones without the brackets are used with the rings. The one with the brackets are used for non-rings, which right there I would have used ring. I don't know, I would have probably used brackets with the rings, but I think it's a Canadian thing, seriously.
So on this list, for the OH substituent, it's listed as hydroxy without the L.
So it's hydroxy. Yeah, it's hydroxy. No L. Do I need what? Yes, I do. I need to put a cis or trans. So this is another trans. Oh, it's there. Yeah, the question was, is this aldehyde hydrogen that I wrote in here there? Yes. And I always put it in just so I know what I'm doing. Remember, every intersection, every end of a line is a carbon atom. Add as many hydrogens to it to give you 4 bonds. They have the lower priority. Okay. All right, we're finishing up chapter 3 for Wednesday, chapter 2 for Wednesday. I will those problems are going to be due on Friday because if I keep the due date as Wednesday morning, they'll disappear before class. So the in the reading problems will be due on Friday, and then the homework problems for Chapter 2 will still be due on Monday. Okay, so, and again, if you have questions, bring me the question or email it to me or come and see me, but bring them on Wednesday and we'll go over them and I'll have some handouts.